Hello, math students. Mr. B here. We are going to go over graphs of functions and talk about some important functions that you should sort of remember what the graphs look like. So first of all, what is the graph of a function? The graph of a function is nothing other than the x and y values that satisfy the recipe you're given for that function. If you take an x value on the x-axis and go up to the graph and then go over to the y-axis, you will see the y value for that particular x. And that ordered pair satisfies the function equation you've got and gives you an ordered pair. And the graph is made up of all these ordered pairs, x and y's, that satisfy the graph function. The graph function, y equals f of x, and then you'd be given some recipe for the function. X squared plus 3, or something. So let's go over some real basic functions. The simplest function possible is a constant function, where f of x equals c, where c is a constant. In this case, I've drawn the graph of f of x equals 3. If we made a table of points, x and then y, remember y is f of x here, and in this particular example, it's 3. So if we pick x equals 2, y is 3. If we pick negative 1, y is 3. If we pick 0, y is 3. It's always 3. It doesn't matter what the x is. So every x value you choose, the y value is 3. So it's a horizontal line that goes through y equal 3. What's the domain of range? Well, you can put any value you want in for x. So the domain is all real numbers, negative infinity to infinity. But the range is very limited, right? It's one value, it's 3. So I'm not even using interval notation. I'm using set notation to say the value 3, and that's it. Okay. Here's another one they call the identity function. They call it the identity function because the y value you get matches the x value that you put in. So if you put in 2, y is 2. So the y has the identity of the x or something along those lines. The function equals itself. It equals its own identity. You put in 0, you get 0. You put in negative 2, you get negative 2. You put in 1/2, you're going to get a half. You put in pi, you're going to get pi. So all these ordered pairs are in there. 2, 2, 0, 0, negative 2, negative 2. I'll quit there and just start pointing out some of these things. Here's 0, 0, 1, 1, 2, 2, 3, 3. Where's pi, pi? Right, maybe there. That's pi. And over here is pi, 3.14, something. How about that negative 1/2? I had 1/2, 1/2. That's here. 1/2, 1/2. And I had negative 2, negative 2. There's that one. You get the idea. It's a line with a slope of 1. The domain, any real number. The range, any real number. You see all x's in this graph. You see all the y's in this graph. Okay. The next important graph in our graph library, our function library, is the absolute value function. So here, y is f of x, which is the absolute value of x. I'm making a table of points. This is a nice way of seeing a few points that you can then connect the dots and get the graph. So if we put in 3, well, the function is the absolute value of 3, but that's 3. If we put in 0, the absolute value is 0, well, that's 0. If we put in -3, now the absolute value is actually doing a little work here. We know we always get a positive value, right? So 3. If we could put in fractions and irrational numbers. So, I don't know, what do I mean? How about -1/2? If you put in -1/2, you get +1/2. Let's see if we can find these points here. 3, 3 would be maybe here. 0, 0 is here. -3, -3 would be up here. -1/2, 1/2, that's here. 1, 1, -1, 1. Right. So you get this V shape that goes forever and ever to the right and to the left and up forever. So what's the domain? Any real number. You can take the absolute value of any real number you want. But the range, because of the absolute value, can't be less than 0. So we would say it's all the non-negative numbers. So from 0 to infinity, including 0. All right, another simple function, a linear function. I've written it in slope-intercept form. F of x equals mx plus b, where m is the slope. It's a number. You'd be given that number, like in this example, it's 1/2. And b is the y-intercept, where the graph crosses the y-axis. That's the b. It's also a number. And in this example, it's 1. Let's find that number, actually. If the line crosses the y-axis at 1, that's this point. To find another point, we can use the slope. M is 1/2. That's giving us the rise over the run. We could get another point easily by going up 1, the rise is 1, and a run of 2 over to here. 1/2 is the same as -1 over -2, right? It's still positive there. So we could go down 1 and left 2 to find this point. Actually, all these intermediate points are allowed too. You can put in any x value. Like if you put in x equal 1, oh, what are we going to get? Whatever that is. If you put in 1, you're going to get y equals 1/2 times 1 plus 1. That's 1/2 plus 1. And if you get a common denominator, you're going to see that's 3/2, which is 1 1/2. Does that look like 1.5 there? Yeah. Anyway, we get a line with a slope of -1/2, and it goes through 1 on the y-axis. Domain, all real numbers. Range, all real numbers. Okay, a really important one. Well, they're all important, but this one's important too. The quadratic function. This is where you take the x and square it to get the y value. Let me make a table of points again. Let me just pick some simple points like, how about x equals -2, 0, and 2. So if we square -2, we get +4. If you square 0, you get 0. If you square 2, you get 4. You can imagine that if you put in a negative number, squaring it's always going to give you a positive, because a negative times a negative is positive. So in this graph, you'll see there's never any parts of the graph are below the x-axis. There's no negative y values. And you get this U shape. You get this U shape. A few more points would show that it's a U shape and not like a V. If you put in 1, you get 1 squared, that's 1. And you put in -1, -1 squared is 1. And so I'm getting this point. There's 0, 0, 1, 1, 2, 4. Well, and -2, 4. You can put in any x value you want, and you'll get points that land on this U shape, which has a special name. This graph is called a parabola. And the minimum value on this parabola, because it opens upward, the parabola opens upward, it's called the vertex. There's some parabolas that open downward, but the maximum value there is what's going to be called the vertex. We'll do quadratic functions, more exotic quadratic functions later in another chapter. I think it's chapter 9. All right, so domain. All real numbers. You can square any real number you want. But the range, just like the absolute value function, is just going to go from 0 up, 0 to infinity, including 0. Because as we said, squaring makes everything positive. If you square 0, you get 0. Okay, what else have we got? The cubic function. Cubic function's another important function. Cubic function's interesting in that the sign of the x is preserved in the function value. You know, when you squared, like in the previous quadratic function, when you square, you always get a positive. If you put in a negative into the cubic function, it will remain negative. Let's see what I mean here. If we put in 2 cubed is 8. If we put in 1 cubed is 1. Put in 0 cubed is 0. We put in -1, -1, we're going to cube that. -1 times -1 times -1. It's 1, but it's negative, because there's 3 negatives multiplying. -2 be -2 cubed. That's going to be 8, but 3 negatives is going to make it negative. So from top to bottom, we're getting this point, this point, this point, this point, and then this point. And all the intermediate values are coming from putting in other values. Like if you put in 1/2, you're going to get 1/2 cubed, and that's 1/8. It's going to be hard to see that, but put in a half, you get an 1/8. What's the domain of range? Well, you can cube any real number you want, so -infinity to infinity. And this thing keeps going up and it keeps going down, so the range is -infinity to infinity. All right, how about a square root function? Let's again make a table of points here. And we know that we can't take the square root of a negative number, so I'm going to just start at 0. And I'm going to think about, just for the moment, values that you can get that are perfect squares, like 1. The square root of 1 is 1, because 1 squared is 1. How about 4? The square root of 4 is 2, because 2 squared is 4. Of course, the square root of 0 is 0. What's another one? How about 9? The square root of 9 is 3, because 3 squared is 9. I'll put in what I'm saying here. 0 squared is 0. So these are kind of the check to see that I got the right function value. So if you put those points on here, 0, 0, 1, 1, 4, 2, 4, 2, and then way out here at 5, 6, 7, 8, 9, it's not that far out there, we're going to get 3. My scale's kind of off, but you get the idea. And you can put any number you want in there that's bigger than 0, and you're going to get all these intermediate values. You get this shape. So what's the domain? Everything from 0 up. We are not putting any negatives in there. And the range, well, the smallest y value we see is 0, and then it goes up forever. So 0 to infinity, including 0. All right. Just a few more here, and then we'll quit. Video's getting a little long. Reciprocal function, 1 over x, has this funny shape. I think you can see, at least for this right branch, what's going on. If you do a table of points, I'm just going to say y equals 1 over x here. Let's try this. What if you put in like 2, you're going to get 1 over 2, that's a half. If you put in 1, you're going to get 1 over 1, that's 1. If you put in, what if you put in 1/2? Well, you get 1 over 1/2. And how many times does a half go into 1? It goes in 2 times. So here's some values for x that are to the right of 0. So when x is 2, we get a half for y. When x is 1, we get 1 for y. When x is a half, we get 2 for y. You start to see this shape. If you put in 1,000,000, you get 1 over 1,000,000. So it never really touches the x-axis. We say that the graph is asymptotic, spelled like this. That's a T. Asymptotic. That means the curve gets closer and closer and closer to another curve, but never touches. It's asymptotic to the x-axis, and it's asymptotic to the y-axis. The smaller the number you put in, the bigger the number you get. So if you put in like 1 over 100, what you're going to get is 100. Just like 1 over 2 gave you 2. You put in 1 over 100, you're going to get 100. The other branch is just, if you put in a negative, you get out a negative. And I think you can convince yourself it's going to have this shape. All right. Another one that you could do a table of values for is 1 over x squared. It's very similar to 1 over x, except when you square the denominator, it'll never be negative. And so the left branch, instead of being like we had before, this kind of shape like that, it flips up to the top. So it's not exactly like the shape of 1 over x, but it's similar. Check out these domains and ranges. Because of the asymptote that is the y-axis, we don't really touch 0. There's x. You can't put in x equals 0. 1 over 0 squared is undefined here. The range, you'll never get 0, but it can go to infinity. And that other graph, sort of similar. The domain doesn't include 0 because you'd have 1 over 0 is undefined, right? Undefined. Not writing very well there, but you get the idea. Let's see, are there any others? One more. The cube root function. It gives you this sort of S shape. And we'll look at roots in more detail later. So, all right, folks, that's it. We'll see you next time.